I welcome you everybody to our geomorphology coffee talk of April on geomorphology. And today we have with us Wolfgang Schwanghart, and he will enlighten us a little bit. But before that one, I will give you a quick outline what will happen today, a little bit of a part, what is geomorphometry and what we're doing and how it will run today. So what are we? We are a group of people which try to do non-commercial, non-governmental association of researchers and experts that we are trying to do something with digital elevation model. We want to understand our quantitative understanding and also sometimes qualitative understanding what happens in the world. We try to advance also the techniques, and that's we're really welcome today Wolfgang here with us to see what he has developed in MATLAB. On that one, we want to try to foster international collaboration across the globe. We have registrations today from India, China, Japan, Brazil, and up to Canada and Europe. And so we hope we can facilitate our communication with each other. You can follow us in our conferences, and you will see in the next slide immediately when it will happen in June. And we also have sessions at the EGU or AGU, and you can talk with us virtually and follow us as usual on our coffee talks bi-monthly, usually on our website or on Twitter and Instagram and LinkedIn and YouTube. And also this coffee talk will then be uploaded later on our YouTube channel, so you can watch it later on. So with that one, our coffee talk here, rules of the day. Today we will have 15-20 minutes presentation from Wolfgang. Afterwards, it will be an open exchange discussion on what he has presented. What are your questions on that one? Please respect your peers, how you treat it. Be kindly with your come up, and I try to make 1-2 sentences as a short wrap up from our session from what we have seen today, what we learned. And please promote the event locally with your students or with other colleagues so they can attend and learn something. And we try to be as broad as possible, from data to methods to software, what is currently on. So if you have a PhD student who wants to present here and outline what he has done or what he's intending to do, please have him coming here. So, but I mean, the next big thing for all of us is our conference. The registration is open. The schedule has been published. You should have all received the acceptance for that one. So please come and join us from the 9th to 13th of June. 2025, actually, should it be, sorry. It will be in the nice town of Perugia. And it will be supported by IRPI, UNBG, IGEO, Society, the Geological Society of Italy, and a couple of other. We will have a DEMs session as well there. So please come there and join us for this event, and we're really looking forward to have you there. And with that one, just one last sentence for me. We have our next coffee talk scheduled. Yufen and Tom Hengel and colleagues and a couple of more people, we have just submitted a paper for peer review on what's called GEDTM30 and multi-scale land surface parameters. So it's a global 1/2 digital terrain model using machine learning, and we propose that we do that as the next coffee talk. We break our series of bi-monthly meetings here, but for the next one in May, we want to do that on the 7th of May. You can already pencil it in your calendars, and if we have the abstract ready, we will send it around and do more things. With that due respect, everything is set from the Geomorphometry Society as an introduction. And let me introduce to you here for today's speaker now, Wolfgang, which works since 15 years with digital elevation models, and if I understood correctly, mostly in the alpine environment. And what he has developed in MATLAB, he will showcase to us today. And I'm really looking forward to see that. Fun fact of the day, we both studied at the same, or worked. I mean, I studied at Potsdam, but we never met. I left in 1999, and Wolfgang, I have no idea when you started, come there and started to work there or studied even there. But I mean, that's people come afterwards, but we have never met in person. So I'm really welcome you. Please, Wolfgang, the floor is yours, and time is running for you.
Okay, thanks. Thanks, Hannes. Well, we probably never met because I only came in 2012 then to
Okay,
Potsdam.
so
So that was
then I was long gone.
long gone, exactly. So let me just share my screen and I hope you can see the presentation.
Yes, we see your
Okay,
screen, we hear you loud and clearly.
okay, that's great. Now, first of all, also thanks a lot for inviting me to this coffee session. I've been following a lot what the Geomorphometry Society and community actually do since my very first beginnings in science, I guess. The blue geomorphometry book is kind of the standard reference for me. Just waiting for a second edition, let's say. But I'm also very glad to see a lot of known faces. Perhaps some of them don't know me that well, but for example, I'm glad to see John Lindsay here, and his the white box tools has always been something that was way up here. And well, I thought, well, what a great tool set. Okay, so what I'm going to talk about today is quantitative interrogation of DEMs using TopoToolbox. So TopoToolbox is the software that I developed. Well, I started to develop, and then also some others were included. In particular, Dirk Scherle, who I'm added here also in the authors list, and Will Kearney, who just recently joined the team as a research software engineer funded by a project by the German Research Foundation, so the DFG. What I will do is I will talk a little bit about the history of TopoToolbox, some of the specifics also, and then where we are actually going, what we try to do, and in the end, and that's why I also like to be here, to activate the community a bit and to take part in the further development of TopoToolbox. But I'll show more about this. So what is TopoToolbox? Well, first of all, it started as a MATLAB library of functions for the analysis of digital elevation models. Why did that actually happen? Well, I cannot exactly tell, except that I was a bit fascinated as a PhD, but as a student already in digital terrain analysis. That's what I liked most when I did GIS work. And so at the same time, I also learned programming. And so I tried to replicate some of the stuff that we did in GIS so that I could do it in MATLAB. At that time, that was my favorite language and the language that I learned and that I still use today, even though I acknowledge that a lot of people have moved to different languages nowadays. And I will talk about that also. Now, over time, a software was developed, released in 2009 for the first time, then also in 2010, together with a paper in environmental modeling and software. And then I moved to Potsdam. From here, development sped up with the work together with Dirk Scherle and a paper in Earth Surface Dynamics about it, about version 2. We also started writing a blog, which you can visit, topotoolbox.wordpress.com. And then, we also developed new tools, TTLEM, for example, the TopoToolbox landscape evolution model. And then the software grew and grew, new additions of certain numerical objects that I will briefly mention afterwards also, adding GraphLut, for example. And since 2024, so you see, this is quite a while that this software exists. Now my telephone is ringing. Is that after 15 years, we have a DFG funded project in which we are actually planning, or not only planning, but also already have accomplished this to some part, to rewrite software to make it available also in Python. So PyTopoToolbox, as well as in R, TopoToolbox R, as well as a computational core written in C, which is called libTopoToolbox. So I will talk about this a bit more than in my upcoming talk. So the development, the last 15 years, what did it actually then incur? Well, first of all, for me, it meant doing a lot of math. As a geographer, not really trained in mathematics, this was a hard thing to do at the beginning. But what fascinated me was, how to get from a DEM like this one. So you can see a shaded relief. Green colors are low, brown are high. And to get from this point to that point. Okay, so I was actually, people are fascinated by certain things, but I was fascinated by this flow accumulation thing that was implemented in every GIS application, but often took ages to calculate, okay? In particular, if your DEM was large. And so I tried to better understand how one would do this and how one could do that better, and learned a lot about sparse matrix algebra, about linear systems of equations, about network flows and stuff like this. And then finally, this, for me, magically equation in matrix notation turned up, which just says, well, the flow accumulation is basically identity matrix minus a transfer matrix. So I won't go into details, sorry. But a transfer matrix, so this is basically a kind of Laplacian matrix. We take the inverse, and W contains, well, what actually goes in. And this is usually just a bunch of ones, okay? And this basically, solving this equation is pretty fast. In particular, since it's upper triangular, and this means using this linear algebra approach meant that we could solve for flow accumulation in pretty fast time. Okay. Of course, it also entailed that I had to look a lot into different subjects as well, because that's not only true for TopoToolbox, but for geomorphometry in general, I would expect. Okay, we have a lot to do with linear algebra, but of course, image processing, spatial data, and georeferencing. And in particular, in TopoToolbox, the way that we solved it with graph theory or network analysis, but also then later on optimization and statistics and machine learning. So these things all somehow play into the development of TopoToolbox and enabled me to look into a lot of different topics in computer science and mathematics and image processing, which I hadn't foreseen at the beginning. Okay, so that was basically the first version of MATLAB that evolved just from applying that equation to digital elevation models. But after a while, we noticed that we could do better, actually, by using, first of all, or better leveraging the approach of using networks and object-oriented programming. And this meant that we developed a couple of numerical objects that still persist today in the software. There are basically three objects. The first one is a grid object. Well, that's basically just a grid, a DEM or any other single band raster, which stores the grid, the projection, and georeferencing. Could also store some units and a name, and is usually constructed just from an external file, like a TIFF file, ASCII file, or text file. And nowadays, you could also have any other supported format like HDF or so. Now, from this grid object, we would create a flow object. Now, flow object is something that you would usually refer to as a flow direction grid, but we stored it in an extra object because we want to use the network structure In fact, we use some kind of topological sorting so that a lot of equations or a lot of operations like flow accumulation, drainage basin delineation, and so forth can be computed very quickly. So a flow object stores flow directions. It's directly derived from a DEM, and it could contain single or multiple flow directions. And finally, there's another object, the stream object. That's important for us as geomorphologists because streams or rivers basically contain a lot of information about, tectonics and so forth. And in that case, a stream object is simply a subset or a subgraph of the flow object. So it's derived from flow directions and stream indicators. It's a subset of a flow object, and it also makes use of this network structure. So it's actually, when you use the software, it's actually easy going. You create a grid object from some file that you have on your computer. You calculate a flow object to obtain flow directions, and based on the flow object, FD, you can then obtain a stream object, which is just a stream network. Okay, this seems like a very linear approach, but actually it isn't, because in fact, all of these objects then also interact with each other. So a grid object, as I said, allows you to obtain flow directions, which then can be used to obtain stream objects. But using these stream objects, for example, one can calculate again a distance to the stream network, which again is a grid object, and so on. So all of these objects somehow interact with each other, and so allow you to make some really nice workflows. And in fact, these different objects are not the only ones that we have. In fact, the object ecosystem has grown over the last years a bit. So there is, for example, also an object which is called PPS, point pattern on stream networks. This is evolved mainly from my interests in spatial statistics, and in particular in point pattern analysis. And so since a lot of phenomena that we have to deal with are phenomena that occur on stream networks, this is a tool set that allows you to analyze these in some consistent way. There's also a divide object. This is something where you can already see, okay, there is a clear connection to the real world, let's say, or the way that we interpret it as geomorphologists, that divides are also something that has a network structure and contains a lot of information about the landscape forming processes. And there's, for example, also a swath object, which allows you to create swath profiles. Okay, this is a lot of theory, so I thought I'm just going to show you how that actually works in practice. So I think you should see my screen now and see
yes, we can
MATLAB.
see.
And so I just want to show you such a workflow in action. Okay, so one thing that we might want to have is some DEM. So, and TopoToolbox contains a tool to read open topography data. So DEMs from open topography, read open topo. We say, okay, an extent is something that we're going to choose. And we can choose from a number of different DEM type. And here we choose the COP30 DEM, for example. Okay, this will open just a small window, which allows us to draw a region of interest. So let's zoom somewhere in here. Zoom to our region of interest, and then we can even make it a bit smaller. I don't want to download too much here. Let's go, where do we go? Zoom to Roy. All right, let's use this one here. Okay. And let's make it even a bit smaller. And select, extend, and close. So this will query the Open Topography API and attempt downloading the COP30 DEM. This, of course, takes a few seconds. let's wait, hopefully not too long. I hope I didn't choose a too large DM, but I think it should work. So this gives you the opportunity to have a coffee in between and wait and wait. Okay, there it is. Okay, here we go. We have a downloaded DM. It is already here. You can see it in the workspace. It is not in a projected coordinate system because that's the way they come from Open Topography. There's already then the notice that one should project the DM to some projected coordinate system. Okay, let's take a look at it. However, nevertheless, just in a geographic coordinate system, the command image sc, a scaled image with hill shade, image sc hs, lets you do that. Here you go. Okay, we are told we should reproject the DEM into some projected coordinate system, reproject to, there's a function called reproject to UTM that makes it quite easy again. We choose a 30-meter resolution, and here we go. The function chooses automatically the best UTM zone, and after a short while, we should have reprojected it. I think I chose a larger DM than I hoped for. Okay. So let me just check the size of this DM. Okay, it's much bigger than I was hoping for. So I'm gonna resample it a bit to 90 meters. Here we go. Okay, that's our DM. You can see that, of course, now some blank areas occurred. That's mainly because of the reprojection. Since I'm a very aesthetic person, and I want to have, axis aligned borders of the DEM, there's also a small function which allows you to extract the largest inscribed grid. So this means we are deleting parts of the DEM, but that makes it just look nicer then. Okay, now based on this, we can derive, as I said before, a flow object, for example. So this is the flow object. As I said before, this object contains a network, the flow network, usually represented by a flow direction grid, but in a different way. So when I double click, then you will see that there is no grid, but that there is a sorted edge list, which shows which pixel basically contributes to which pixel. Okay, based on this, we can easily calculate flow accumulation, and you will see that this is actually quite fast. Okay, it's just a matter of a second. That's what I actually was aiming for when starting to develop this toolbox. And so we give it a different color map, flow color, and we display the logarithm of this flow accumulation grid. And here you go. So you can easily zoom in and see that this looks quite nicely. Okay, based on this, we can then obtain also a stream network, a stream object. We take FD and give some, some minimum upstream area where channels should begin. Maybe just say, okay, once 1,000 pixels flow together, so when there is a flow accumulation of 1,000, then we should have a stream to be initiated. And the stream object, the resulting variable S here, can now be easily plotted. So you have your stream network. You can extract the largest basin, let's say. I call those connected components because that's in graph theory terms. So we are just taking the biggest one. This is the biggest one. And then, for example, also plot a channel profile. So meaning we take our stream network and plot the distance versus elevation. Okay, and that's basically the channel length profile. So you can see that TopoToolbox allows for pretty easy workflows and actually quite fast implementations of doing that. There's a lot more to explore, but I want to leave it here. You can also export this data back to shapefiles or whatever format you like, and then continue your analysis. Okay, but let's go back here, because what is now TopoToolbox else doing? Well, one of the stuff that we realized was, well, we are reasonably fast with our with our algorithms, and so we could actually use these to get dynamic, okay, to create dynamic models of the Earth's surface. And so the image that you see here is actually such a simulated topography. This is not real topography, but one that has been simulated using a landscape evolution model. Okay, and for example, that's what we are currently just working on. A lot of the topography evolves through the interplay of tectonics on the one hand side, climate on the other hand, as well as differences in erodibility. And what you see here, this is the Eye of the Sahara. It's a big dome structure that has been eroded. And what you can see is that, you have these circles of different lithologies being visible then at the Earth's surface. And so we developed currently TTLEM 3D, which allows you to use not only surfaces, but entire 3D stacks of lithology, and for example, to drive landscape evolution models with that. So this shows a topography which evolves when you have an uplifting dome structure, which, where you have a topography evolving over time. So this is TTLEM, the TopoToolbox landscape evolution model over time. And this is basically something that we want to also pursue in the future. For example, TopoToolbox now also contains a 2D hydrodynamic solver. This one has been developed by Boris Guy et al. And recently been published in Earth Surface Dynamics. It shows that, well, when we deal with high resolution topography, we might often not really capture the high resolution or the hydrodynamics well by the approach of just routing water along a single pixel, or even multiple flow directions won't do that well. There's some music being. Okay, and so Boris Guy et al. Developed based on the multiple flow direction algorithm a tool that allows you to simulate hydrodynamics. And so here the colors just show the different flood extents by different precipitation rates. Okay, so I think that's something that is in particular important when we talk about flood mapping and using high resolution topography. And also other stuff that we have been recently including in TopoToolbox as a modular feature is, for example, a rock avalanche model, which was developed by Stefan Hergarten. Now you should also see that in action. It's here, that is the Eiger North Face, and you see this rock avalanche coming down, simulated with a modified Völmi rheology. So truly physics-based and quite nice for applications in hazard and risk analysis. So what other applications exist? So we have a lot of applications in hydrology when it comes to pre-processing of DEMs for hydrodynamic models. We have done stuff on glacial melt water flows, simulating glacial lake outburst floods, modeling preferential groundwater flow path. So people were quite creative in using TopoToolbox for stuff that I never thought it would be good for. Has been used for regionalization and analysis of ungauged basins, but also for risk assessment of hydropower projects, for example. And the other part is mainly in geomorphology and geology, so analysis of river profiles, in particular river steepness, to understand landscape response to uplift and climate changes. A new field of research, which is currently where a lot of is happening at the moment, that's the analysis of divide dynamics, so-called Chi analysis, and also other metrics that describe landscape or terrain divides. It has been used for landslide susceptibility analysis, also flood wave propagation and sediment dynamics, as well as for very long time scales for the long-term simulation of landscape evolution when it comes to planning of nuclear waste repositories. And I've also seen other applications in glaciology, for example, in meteorology or the planetary sciences. So all these disciplines where the Earth's surface and its geometry are important. Now, let me say a few final words about
Yes.
TopoToolbox.
You're a bit over the 20 minutes, so.
Okay. Let me say a few final words about TopoToolbox 3. So we are now a small team. Dirk Scherler, Annalena Lamprecht, she is a professor for research software engineering. Will Kearney, who is our research software engineer, and also a student assistant, Theodore. And well, we are running this project for quite a while now, since 1 year about. And the aim is to offer TopoToolbox in multiple languages, so in Python and in R. We will develop, or we have developed, a computational core in C, and also plan to enhance the software by some algorithms that allow us to use big data, in sense of data that doesn't fit into your memory, and also being more flexible when it comes to spherical geometries. We try to adhere to the FAIR for research software principles so that everything is findable, accessible, interoperable, and reusable. And finally, that's what I want to emphasize here, to engage the community in the active development of TopoToolbox. And for this, I just like to call out, get involved, take a look at our organization. We now have this GitHub organization, TopoToolbox, that also includes some contribution guidelines. And get in touch if you want to contribute somehow. I can only state here, the MATLAB version is basically the one that is currently most advanced. PyTopoToolbox needs additional work. We can really need your support here. And TopoToolbox R really still needs a lot of work. Okay, that's the one that we least focused on in the last year, but we want to put more emphasis on this one. Or if you are into C, consider contributing to libTopoToolbox. And even if you don't code at all, people are needed to help in testing and documentation. Or if you have any other advices for how to get the community involved, I'm very happy to get in touch. With that, I'm finished. Thanks for inviting me once again, and I'm happy to receive your questions.
Okay, thank you, Wolfgang. Thank you for your interesting presentation. Okay, we have got some really in-depth insight into what Wolfgang and the colleagues at the University of Potsdam are doing. And I leave the floor open for questions for everybody. Please go ahead, raise your hand, and I will put you up on stage for whoever wants to do something. Have the floor. Mm-hmm.
That's a good question. It's I think that we can couple libTopoToolbox pretty easily to GDAL. So I think it is straightforward also to somehow use it as a plugin or implement it as part of a plugin, in particular when the Python implementation is finally working well, to plug that into QGIS. And I think that would be a great add-on actually to to do. I mean, a lot of the algorithms are somehow already available also by other toolboxes, in particular looking at white box tools. But of course, for some kinds of analysis that have a strong, let's say, tectonic geomorphological focus or so, I think this could be something that people would also appreciate to have as an extra plugin or toolbox. Yeah.
Okay, thank you, Wolfgang. Next one, hands up, please. I don't see anyone.
I cannot see my hand as well, but can I just go on?
Yes, please go ahead, Debayan.
Yes. Yeah. So hi, Wolfgang. I've been a big fan of your blog posts actually, and this was a very nice refresher of the stuff that I learned during my master's at the university. So I just wanted to ask, because the landscape evolution stuff that was like not really being taught at the university as a part of the DEM class that we did. So are you like doing some workshop or something like a hackathon or something where you teach this landscape, like the TTLEM stuff and all that in Berlin or in Potsdam or in Golm somewhere?
Yeah, that you're right. Most courses that use TopoToolbox, and basically also I taught a lot of courses at the IIT Roorkee, for example, and I always did or use just the normal TopoToolbox works, but never touched really on TTLEM. But that will I can change that. First of all, I could try to make more information available via the blog on that. And yeah, at some point, I think it could also, I mean, well, I do one course in at the University of Potsdam for master students where I also use TopoToolbox, and they actually use a bit of the TTLEM stuff. But that's in geoecology and not in the geoscience department, unfortunately.
Maybe you could do it next time at the geomorphometry conference. I'm not sure if Massimo can still accommodate it for you this time, but maybe keep it on the short list for in 2 years' time for the next geomorphometry conference to teach a course on that one. Is that there, if you're interested?
That's actually a good idea.
The conference will be.
Yeah, but
No?
I won't be able to come to Perugia, so I was quite glad to. I am at least co-authoring a paper, and I also see the main author Michele Del Chiaro here. So
Okay. So thank you. Further questions? I don't see anyone. Yeah, Abai, please go ahead.
Hello.
Yes, hello.
I'm
Please take the floor.
Hello, everyone. So thank you so much, Dr. Wolfgang. So my question is, I'm currently working on the field of natural hazards. As you said, one application for the TopoToolbox is for globe simulation, a glacial lake outburst flood. So can you guide me how it works and how can we use this tool for the globe simulation? And from where I can get the supplements and
yeah.
Yeah.
So in the end, you're right. It was used for GLOF studies. I have used it, even though some of the code is not really published, still from some time when you didn't publish like everything. But it actually, I mean, you can send me an email and I can try to forward you the code that I wrote before based on stream objects and some very simplified flood wave propagation model that simply tracks how the peak flood, for example, triggered by an outburst event, would attenuate downstream. There is some semi-analytical approach according to Victor Pons, and that one is adopted here. And so that's how I actually used TopoToolbox in conjunction with these glacial lake outburst floods. But you can drop me an email and I can try to make that again available and running.
Yeah, sure. I will write. And if I can add something, I will try also. Yeah. Thank you so much.
Okay. Thank you. I assume John next, please.
Thanks, Hannes. Sorry, I don't know where the hand raising feature is here. I guess I mustn't be the Zoom ninja I thought I was. Wolfgang, I really enjoyed your talk. In particular, the part of it that I most enjoyed, in truth, was well, obviously the demonstration was fantastic, but also just your description of your journey to how you got to this point really certainly paralleled my own journey. So I really enjoyed that. Just wanted to say that I've obviously been a big fan of your work for a long time, and that I've been paying attention to what goes on with TopoToolbox, and it's pretty remarkable software. I wasn't as aware of the landscape evolution components that you demonstrated today, so that was great to see. I had wanted to ask you whether or not you're going to be in Perugia, but it sounds like you aren't, so that's disappointing to me for sure. But some other time we'll have to meet up.
Yes, definitely. Thanks, John. It's as I said before, I followed a lot what the geomorphometry community does, but was never really felt really involved because I also did a lot of stuff in the geomorphology, of course. But I see that there are more intersections, at least, that we could actually also benefit from. And so I hope you choose a very nice location for the next geomorphometry conference, which you said was every 2 years, right?
It's every 2 years. I don't remember where we settled on for our next one. Might be France, but I might be wrong on that one. I'm not sure. Hannes would probably know. Yeah, I'm not sure where it is, but yes, you absolutely should find the intersection with geomorphometry to be strong and attend whenever you can. And what you just spoke to, I think, is something that in the community for geomorphometry we've been trying to overcome for quite some time, which is, obviously geomorphometry techniques are applied in many different places, but we really want to get those application areas to see those intersections and to participate in our community as well. So thank you.
Yeah, thanks.
Good. Someone else wants to have the floor. Raising your hand or just speaking up your mic, please. You can just come up, turn on your video, or just start speaking. Otherwise, I have a question for you, and one or two questions. I mean, what kind of special functions you have developed on TopoToolbox, which are not existing in other geomorphometry packages? I understood, so you have done something special on tectonic and geological landscape development. So I mean, but there's also some other software to do so. And then the second question I had is, at one stage you made the comment that your software is quite fast. Have you compared it to other implementations like what we had seen from John's Whitebox tools or Saga or some? Yeah, I'm not talking about ArcInfo, but I mean some more newer properties.
Okay,
So
coming to your first question, what other tools basically exist that would be different to those that are usually available in?
No, what you have done additionally. Sorry, I mean,
exactly.
What makes you your single point of sales for TopoToolbox?
So I think the most important part is that I can use, or I have some tools that access, let's say, functionalities that are not, let's say, the standard part of, well, difficult to say. I mean, if you use Python, then basically the world is open to you. But in MATLAB, what I'm using is a lot of optimization techniques. So for example, for DEM pre-processing and yeah, is either we use filling or we use carving, and using techniques such as what is it called? I call it a constraint regularized quantile regression, which allows you basically to, neither to overemphasize the positive errors in the EM nor the negative errors, but somewhere in between. And that's so something between carving and filling. That's what I found very good to do and implement in MATLAB and TopoToolbox, just using tools like quadratic programming also, which come from optimization techniques. So these are some stuffs that I think are really advantageous to work with in these engineering software packages. Yeah. And what was the second question?
The speed. You were saying, yeah, it's fine, it's speed. I mean, what happens if you process, let's say, all over Europe?
Yeah.
Yeah.
So I've made that comparison like quite a while ago. And for example, for getting flow directions, I think we are mainly like when comparing to white box tools, it's basically the same, I would say. But when it comes to calculating flow accumulation, at least these days, I was 10 times to 20 times faster. This might have changed. I haven't done any comparison because that comparison is sometimes also not quite fair because we have all of our data in the memory. Whereas, I mean, if you use ArcGIS, then you have input-output algorithms that make it possible to use data which is as big as possible. But that, of course, comes at speed. And so this is also one of the main limitations. I mean, the biggest DEMs that we can take is limited, first of all, by memory, and then second, by integer overflow at some point. So if we have more than 65,000 times 65,000 grids, so pretty large, but then we will face an integer overflow, and that's a hard limit, let's say. But for example, working on the entire Himalayan arc or so, using a 90-meter DEM, you can calculate flow accumulation in 6 seconds or so. That's pretty fast. Yeah.
Okay, that sounds reasonable. But on the memory, you can go to AWS or Azure and get a big machine or on an HPC computer with as much as memory as you want nowadays.
Yeah, the hard limit is the 65,000 or the
I understand that.
32 representation. Yeah.
Okay, I understand that one. Someone else wants to have the floor for today's coffee talk. No one wants to have the floor. Participation has increased, Wolfgang. We have reached at one given moment, we are now at 22. So maybe that's due to the timing, but I mean, over the time, more and more people have joined. So thank you everyone for joining today. So if there's no more questions, let me wrap up today's coffee talk because we are 5 minutes to 4 o'clock, at least Central European time. We heard today Wolfgang talking about what he has done in TopoToolbox and where he inquires or encourages you all to participate in development, what they're doing in TopoToolbox, also where they're doing some programming now in C and putting Python and R libraries on top of that one, if I understood it correctly, that one. And hopefully we will see someone doing a QGIS wrapper to that one on ArcGIS. And what we learned as well, that you were focusing on speed and that you can do tectonic and geological landscape evolution modeling as well, flood and glacier modeling with that one. And with that one, thank you, Wolfgang. I would thank you for today's discussion, for your presentation. Thank you for being here, for the nice, interesting discussions and questions from the audience. And let's see that we can meet again in 1 month from now on the 7th of May. Almost 1 month, a little bit more later, because today we have the 2nd, for the next geomorphology coffee talk, then by the colleagues from Open GeoHub. With that one, let me just see, I see just a chat message popping up. Yeah, so nothing there. Then with that one, thank you very much and have a nice day, everybody. Bye-bye.
Thank you. Thanks a lot. Bye-bye.